Hello friends, in this video we are going to discuss about how to find out state transition matrix phi of t. So phi of t can be found out using this formula, Laplace inverse of bracket Si minus A. This is the matrix and its inverse. So for finding out phi of t, first of all we need to find out the matrix Si minus A, and then we have to take its inverse, and after that we have to find out Laplace inverse of that matrix. So we'll see one problem which was asked in the SPPU university examination. So let's say this is system matrix A, which is given to you 0 1 minus 8 minus 6, and you have to find out the phi of t, or state transition matrix of this given system. So first of all, we'll try to find out one by one. First of all, we'll try to calculate matrix Si minus A, then we will try to find out its inverse, and then we will take the Laplace inverse of this matrix, and hence we can have the phi of t. So Si minus A, so S is the Laplace operator, I is the identity matrix, minus system matrix A. So we have to take identity matrix in such a way that the size should be equals to the matrix A. So this is 1 0 0 1 is the identity matrix. So if I multiply it with S, it is going to be S0 0 S, and we have to subtract it from the matrix A. So if I subtract it from the A, hence we can have Si minus A. So S minus 1 8 S plus 6. So this is Si minus A. Now we have to find out its inverse. So finding out inverse matrix, that we have seen in the previous video, how to find inverse. So adjoint matrix of Si minus A divided by determinant of Si minus A is the inverse matrix. So first of all, find out adjoint matrix. So finding out adjoint matrix means we have to find out cofactor matrix first, and then we have to take its transpose, that will be the adjoint matrix. So finding out cofactors. So cofactor, so this is 2 by 2 matrix, so it has 4 cofactors. So first cofactor at 1 comma 1 will be S plus 6. Cofactor at 1 comma 2 is minus 8. Cofactor of 2 comma 1 is plus 1. Cofactor of 2 comma 2 is S. So this is what the cofactor matrix, S plus 6 minus 8 1 and S. If I take its transpose, that will be the adjoint matrix. So if I take the transpose of it, it is going to be adjoint matrix S plus 6 1 minus 8 yes. Now the inverse matrix is the determinant of finding inverse matrix is nothing but adjoint matrix by determinant. So determinant of the Si minus A is S into S plus 6 plus 8. So if I solve it, we can get the second order equation. So this quadratic equation has two factors, S plus 2, S plus 4. So this is the determinant of Si minus A. Now if I put in the formula of inverse, this is adjoint matrix divided by determinant. So if I divide with this quantity, so we can get the elements like this. The first element will be S plus 6 divided by S plus 2 into S plus 4. Second element will be 1 divided by S plus 2 into S plus 4. Third element will be S minus 8 divided by S plus 2, S plus 4. And fourth element is S divided by S plus 2 to S plus 4. Now we have to put in the formula. So phi of t is nothing but Laplace inverse of Si minus A inverse. So this is the inverse matrix. Now we have to find out its Laplace inverse, that will be phi of t. So finding out Laplace inverse of the matrix is nothing but we have to find out the Laplace inverse of individual elements. So these are the 4 elements. So we have to find out Laplace for these 4 elements, and that will give us the phi of t, that will be in time domain. So first element is S plus 6 divided by S plus 2 into S plus 4. So this is the simple problem which you might have solved in signals and systems. So it is simple problem of Laplace, so it can be solved using partial fraction. So if I solve using partial fraction, so if I put S is equals to minus 2, S is equals to minus 4, we can get the values of A and B like this. So A is equals to 2, B is equals to minus 1. If I solve this, we can get A is equals to 2 and B is equals to minus 1. So if I put in the here, so we can get a is equals to 2 and 2 by s plus 2 first factor, and second factor is minus of 1 by s plus 4. So if I take its inverse, it is going to be simple 2 into e raised to minus 2t minus e raised to minus 4t. So this is first element. Likewise, we have to solve the element number 2. Again, using the partial fraction, we have to represent in terms of a by s plus 2 plus b by s plus 4. So if I put s is equals to minus 2, b is equals to minus 4, we can get a is 1 by 2, b is minus 1 by 2. So if I put here, it is going to be, so if I try to find out 1 by 2 as a common part, so it is going to be 1 plus s by 2 minus 1 plus s by 4. So if I take its inverse, it is going to be e raised to minus 2t minus e raised to minus 4t into 1 by 2. So likewise, we have to find out the Laplace inverse of the third element. Again, we have to represent in terms of a partial fraction. We can get its inverse very easily. So a by s plus 2 plus b by s plus 4. If I put s is equals to minus 2, b is equals to minus 4, we can get a is minus 4 and b is 4. So if I put in the equation, it is going to be minus 4 by s plus 2 plus 4 by s plus 4. So if I find out its inverse, so minus 4 will be, or we can take 4 as a common, and the inverse will be e raised to minus 2t plus e raised to minus 4t. So if I take 4 as a common, so if I multiply with minus, so it is going to be e raised to minus 4t minus e raised to minus 2t. Likewise, we have to find out Laplace inverse of the fourth element. So again, we have to use the partial fraction to solve it. So if I put s is equals to minus 2, s is equals to minus 4, we can get a will be minus 1, b will be 2. So if I put in the equation, its Laplace inverse will be like this. So minus into e raised to minus 2t plus 2 into e raised to minus 4t. So if I put everything in the formula, it is going to be phi of t like this. So this is 2 into e raised to minus 2t minus e raised to minus 4t is the first element. So 1 by 2 into e raised to minus 2t into e raised to minus 4t is the second element. So 4 into e raised to minus 4t minus e raised to minus 2t is the third element. And the last element is 2 into e raised to minus 4t minus e raised to minus 2t. So hence this is the way how to find out state transition matrix for the given system. Thank you.